Welcome back to the European Spaceflight podcast. I'm your host, Andrew Parsonson. Today, I'm excited to welcome Pangea Aerospace CEO and CCO Adrià and Xavier. Guys, can you kick off a bit by talking a bit about the company and what the goals of Pangea Aerospace are?
Absolutely. So first of all, thank you for having us. It's a pleasure being in European Spaceflight and having the possibility to explain a little bit about us. So Pangea Aerospace was founded 4 years ago. And when we founded it, we wanted to build a micro launcher, but pretty soon we understood that it's a very crowded market, as you well know, and we want to really to differentiate ourselves. And we started developing a new type of rocket engine, which is the aerospike, that it's not completely new. I mean, many people has investigated before, but now thanks to new manufacturing techniques, it could be a reality, it's a possibility. The reason why going directly into this type of propulsion system is because it's more performing than conventional rocket engines. And we do believe that the key for actually being a successful company on the long run in the, let's say, space sector and the launching sector will be to be super performing. We're having a super good advanced propulsion system that it's performing, and reusability will be key to actually be a long-term business.
Perfect. I mean, in terms of the size of the company and the funding you've been able to achieve thus far, can you talk a bit about that just to get the scope of Pangea Aerospace thus far?
Absolutely. So now we are 30 people. We expect to be around 40 by the end of this year, and we want to double that in a couple of years, so from next year onwards, I would say. So far, we've raised a little bit more than 8 million euros, both in private and public money, and we are currently fundraising our Series A.
Perfect. And in terms of the roadmap you guys are working towards for Pangea Aerospace, for the MESO rocket and for your Arcos engine, can you speak a bit about that roadmap, what it looks like and where you're going from there?
Absolutely. So
first, Adri, sorry, hello here, it's Xavier Llairo, CCO of Adrià Argemí. Before going into details about the roadmap, I think it's important to explain a little bit our approach. So as Adrià was saying, when we created the company, we understood that many micro launchers, they were focusing on using technologies that are already validated in order to arrive to the market very quickly. But as we understood that this is not an option actually for a micro launcher, because the price that these companies are targeting is between 3 to 10 times higher than what SpaceX and even heavier launchers are proposing to the market. So what is the service that these micro launchers are actually giving to the small satellites that want to reach orbit? Basically, it's flexibility, but even there, the recurrences of launch is not such of a service to justify a price tag that is way higher, right? So for micro launchers, in order to be competitive, we need to also find disruptive solutions to bring down the cost. And here is where the propulsion system enters and reusability enters into place. I think we have to be a little bit bold in the micro launcher industry, because a micro launcher is also a test bed, maybe for heavier launch vehicles that can be more performing in the future. And this is our approach from the very beginning. We're creating the assets that are IP assets on propulsion systems that are more performing, more sustainable, and designed towards reusability. And these propulsion systems that we're building, of course, they are good for small launch vehicles, but if you scale them up, they are even more interesting in terms of delta of performance. So our approach is not to be the classical micro launcher doing from design of engines to launch operations and commercialization of its own payload capacity, but focusing on the hardware part in order to give the best hardware, the best reusable hardware, the most performing hardware at a very low cost. And this example and position in the value chain that today is maybe not clear or not totally understood because it's quite unique. It's something that exists in other industries such as aviation or the automotive industry. And this is where we want to place ourselves. So now coming back to the roadmap, last year we validated, we're the first ones in the world to validate aerospike technology. And we actually tested the first aerospike engine that is using liquid methane and liquid oxygen. And it's very important, the fact that it's regeneratively cooled, because there are other aerospike engines out there, but they are cooled with water, meaning that they cannot actually work operationally. Our Demo P1 engine is an engine that has very stringent requirements, a very high chamber pressure, that is using regenerative cooling, that has a really good mixture ratio that can be throttled down, that was tested 9 times, and that could actually already fly. But we decided not to fly this engine because we are going for something bigger, more performing, and more optimized. So the idea is to test, to certify Arcos, which is a 30-ton engine, so 300 kilonewton aerospike engine, fully additively manufactured in very little pieces by 2024. So a lot of hot fire testing, certification of this engine, and making it fly by the end of 2024 or 2025. This is our roadmap. And this is what is validating the technological block, which will be the core of Pangea Aerospace offering, the engine and the first stage of the launcher. Also because we will test the aerodynamics on re-entry, which is very hard, such as Rocket Lab has done recently.
You talked about re-entry. Obviously, you are aiming for reuse. Do you want to talk a bit about your approach to reuse and how you'll be doing it?
Absolutely. I mean, first, let's say coming one step backwards on all the explanation that Xavi has given, the propellant choice is important as well for reuse. And here it's important to mention that having chosen Methalox, it's very crucial for the reuse purposes, because methane being, I would say, the most performing hydrocarbon, it really eases reusability because its sooting point of the propellant is way lower than compared for Caro. So it really doesn't leave any traces of soot inside your cooling channel. So your engine could be reused much more often. So now we are investigating, thanks to a project, a European project, 2020 project, many ways on reusing and many ways on how actually you land a first stage, which could be, of course, mid-air catch, which could be retropropulsion. And here, one interesting topic to mention that Xavi has briefly said is re-entry. And having an aerospike here, it's another technological decision on how to develop our, let's say, solution portfolio, because it really, thanks to it, just a V shape, as you potentially guys know, the aerospike has this V-shaped, just by intrinsically its shape, it eases the re-entry, because the loads, more, I mean, aerodynamic loads and also thermal loads are a little bit easier to handle, because you already have a regenerative cooling system ongoing into the spike. So it really, from a material point of view, eases that way down. And even it could allow you to do a passive re-entry. And this is key because for very small launchers, or let's say under a ton, more or less, if you have to do a re-entry burn, it really costs you a lot of penalty into your payload. So you potentially may know, and SpaceX is actually reigniting many times their engine. So of course, going up, the boost back, the re-entry burn, and then the landing burn. So the re-entry burn, it's pretty long. So really affording this into a micro launcher is almost killing your payload ratio. So having an aerospike allows you to do it passively and then even think on retropropulsion. So nowadays, to sum up what I just said, we are investigating several ways, but mid-air catch, retropropulsion, I would say, are the two main ones.
Absolutely. Also here, if I can add very quickly, reusability is hard for launch vehicles. Not only hard in terms of technology, which it is, of course, re-entry and landing are very hard, definitely, but also in terms of economics and logistics. And I think these are the four main variables that we have to take into account, and it's all intertwined, right? And the ROTB project that we are leading, so it's a grant from the European Commission that gave us some funding to develop these systems. We're working with top organizations in Europe, such as Von Karman Institute and Deimos Space or Thales Alenia. And what we're investigating is this passive reentry, which is fundamental, as Adrià was mentioning, but also the economics. So what is the payload penalty that you have in order to have one recovery system or another recovery system? What are the different reuses that you could do of your vehicle? What is the flexibility also? Because maybe if you are able to remove your recovery system, you can gain payload capacity on the 10th flight or 11th flight of the same hardware, right? So all these elements are very important. And I don't want to forget the logistics as well. Where are you landing? How are you then recovering your vehicle? Is it in the sea, in a barge in the sea? Is it directly with salty water, which is something that is very surprising? How can you reuse a propulsion system that has touched actually salty water? It's quite complicated, and the refurbishment process that there is behind this is first unknown, and secondly, very, very hard to ensure that this system can properly work again. And last but not least, where is your refurbishment facility? How do you refurbish your launch vehicles, and how long does it take, of course, and how much does it cost? So all these elements are key for us, and this is why we needed also to start from a blank piece of paper and think about a full solution for going up and going down, not just thinking about a solution to go up and then thinking, wow, now we have to go down and reuse it. No, it's very important from design to take into account all these elements.
Perfect. I mean, you talked about reuse and you talked about 10th, 11th flights. I know on the website, it does say that you're looking to reuse there and there about 10 times. What sort of refurbishment is involved with each flight, and how long are you expecting to take between those refurbishments and between flights?
Okay, so I'll start with that one. It's important on why we chose 10. I mean, and why we put that 10. So as Xavier just said, we are currently, and we've done several investigation and analysis on taking as much variables as possible, not only from the technical side, but also the logistics. And we're seeing, according to our computations, that from the fourth flight, it's absolutely worth it to have reusability. So we said, okay, let's be ambitious, but not be super ambitious in the sense that why don't say 1,000, 2,000 times? We prefer to be conservative in this side. So we have a very ambitious goals on the long term, but we want to really have still our foot on the ground and being conservative when we can and also apply margin. So 10 really makes complete sense from a, let's say, economical point of view. And as the minimum, as I said, it's about 4-ish, more or less, and that it's worth it. And then to answer on the refurbishment, we are targeting, of course, the least amount of time between flights, but I would say in order of weeks between flights, not months.
Perfect. And is the Methalox choice a big part of that turnaround time, is that you don't have as much refurbishment as something like a traditional RP1 would take for an engine with that build up?
Correct. That is correct.
Absolutely. Actually, let me also discuss a little bit, because from what I read in the market, I'm always surprised. It seems that all the engines are extremely sustainable, and I want to say that this is not true. A solid engine, of course, is the least sustainable one. Then you have hybrids, and then you have liquids, which are the most sustainable ones, right? In liquids, then you have kerosene-based fuels, which are not very sustainable. It's hydrocarbons. They are not that sustainable. They are not as efficient as using hydrogen or methane, for sure. And they leave more cooking or soot inside the channel, so more difficult to reuse, right? And it seems that sometimes these kind of basics of rocket engines are forgotten. And I just wanted to mention it. Last but not least, what we see in the market, almost all the small launchers in Europe are using either hybrid solutions, so not very sustainable and definitely not reusable, up to my knowledge, and or RP1 propellant, which really doesn't ease reusability. It can be done, of course. SpaceX has done it, but it involves more refurbishment time because the engine is, let's say, the material is more used, to say it easily.
Yeah, methane is really available almost everywhere in the world. You can even start thinking about biosource methane, where you can think of carbon neutral rocket engines, carbon neutral launchers. So for us, the sustainability part is not a buzzword, absolutely not. It's comes from when we create a company, when we believe that methanox is the key enabler and for reusability and for having a almost on the long run, why not even daily basis operations, thanks to all these technical decisions that have been made on the road.
Absolutely. So, and on this sense, I understand that many organizations went for a RP1 based solution because it has more heritage and it's easier to handle as it's not cryogenic. But it's like betting, to my point of view. Of course, we can disagree, but it's betting on technologies that are probably already obsolete, unless you do an amazing engine with very high ISP, which is not the case on many organizations out there. So yeah, the idea of Pangea Aerospace is to work really on the technologies that will be the base technologies from in the next decades, not on technologies that are already obsolete when arriving to the market in the upcoming years.
Perfect. Recently you updated your website, which, I mean, the new website looks great, but I wanted to talk a bit about the MESO rocket jumping from 150 kilograms for the payload capacity up to 400 kilograms. Can you speak a bit about what's brought on that increase in capacity?
I'll start by the economical part, and maybe I'll let Adrià on the technical side. So the market has seen a big evolution in the last, I would say, 2 years, since 2019 even, I would say. And the idea behind is that, of course, actors that are already launching, that are operational, want a piece of the cake of the small satellite market, right? So they develop solutions to be able to launch this kind of payloads as recurrently as they want, and bringing them to the orbits that they wish, right? So which kind of solutions that have been developed? OTVs, deployers, and all these kind of things, right? This is the way big launchers are trying to take this market. So small launch vehicles find themselves in a position where all the advantages that we're supposed to have are not actually maybe there. So this is one point. Second point, it's very difficult to make money with such small payload capacity, and Rocket Lab accounts are a clear example of that, right? Their price point is quite high, and still it seems that operationally they lose money on each launch because this market is complicated. So you need a little bit more of payload capacity in order not to lose that many economies of scale, right? And I think this is the idea. From a market standpoint, it makes sense to go, from a cost structure standpoint, it makes sense to go to higher payload capacity. But then again, which are the payloads out there that weigh, I would say, 200 to 400 kilograms? Well, not that many, meaning that probably rideshare or piggyback options will still remain for these small launch vehicles. So yeah, just to mention, to have a mental scheme on this, I think it's important.
Yeah, and as Xavier was saying, of course, this was very important and technical. Technically speaking, we wanted to develop an engine that would offer it to agencies, to other clients. And we did a study, and we believe that 30 tons, it's very interesting. It's putting us into a very good market point, and that is more or less, it translates to this 400 kilos. And of course, for us, it's just the beginning. As Xavier was saying, we are building this technology blocks. We start with the engine, then we put it into the booster. And the booster, of course, could be interesting for the next generation of European launchers or even non-European. And then adding an upper stage that could be very interesting as well to studying reusability, not only on the first stage, but as well on upper stages. So for us, it was the first step. The first step is this going into the micro launcher sector, but we are seeing with the aerospike that actually the bigger you make it, the more performing it becomes. The delta in performance is increasing. So actually we are working, for example, with the French Space Agency on that, and to the studying how it will scale up on the meganewton class, so the Prometheus class, or even larger, so 1 to 3, 4 meganewtons. And we're seeing that it's very interesting because, as I said before, it allows you to be super performing on your way up, but also easing your way down. And this, if we really want to have recurring, as I said before, daily basis operations, having the best technology is absolutely necessary if we all believe that this will happen in the coming years. We cannot hear you.
You're muted. Yeah.
You talked about offering your propulsion system to clients and to customers and not just using it for your own launcher, MISA. Can you talk about a bit about that? And have you had interest from customers?
I'll start with that and then you jump, Xavi. So I think it's important on why we decided to go this way. And we don't want to do everything. So we're seeing that everyone is doing vertical integration, doing everything in-house, and we understand why. We are working on what we say is the next generation of technology. So if there are other partners, companies, suppliers that are very good at doing very subsystem, why should I do it again? So we really want to focus on what we're good, and where we're good and really what we have a technology that no one has is the aerospike. Then we will add it to other subsystems. So we don't want to be constrained by our own operations. So we really want to have a very strong supply chain to actually be able to target someone that could be interesting only in the propulsion subsystem, someone that could only want to, add on our booster, reusable booster to actually increase its payload capacity, or someone that it's an operator that says, hey guys, I just want to buy your rocket. I'll do all the commercialization. I'll put all the payloads there and I launch it and operate it. For us, it's really widening our client portfolio.
And why that? I think it's very important. We are copying here in Europe models that exist in the US, but without the same capitalization. And I think it's not realistic. When Rocket Lab, which is, or SpaceX, but Rocket Lab, let's take the example of Rocket Lab, says that they want to do everything from designing the rocket engines to operating their launch vehicle, commercializing their payload capacity, and so on. These are very different businesses, very different activities that require different skill sets, different infrastructure, and different ways of doing. And to be honest, we don't want to smear our limited resources up until now. Still, we are well funded. We're doing a fundraise, the Series A fundraise, but if we smear our resources, we'll arrive nowhere. We have already lots of challenges to tackle, and we have to focus on what we're good at. This is one point. The second point is that despite the fact that this industry exists since the 60s, let's say, the launching industry exists since the 60s, it's not yet a mature industry because the number of launches that are performed worldwide each year is still very low, not comparable at all with flying a plane, right? Or even less with the automotive industry. And when we look at these more mature industries, we see that the value chain is disaggregated. So SpaceX did vertical integration because I think they realized that there is an hypertrophic value chain where actors have been subsidized or won public money. So the offerings in terms of products and services are not very competitive in the market. But this is changing because there are actors all over the value chain, from building launchpad, mobile launchpad or sea pads, to avionics, to tanks manufacturing, to additive manufacturing of components and so on, that are working to bring competitive pricings. And here is where we enter. We want to implement a model. We will not explain the whole details here to the public, but we want to implement a model where we tackle only one part of the value chain. And this idea is to provide the best reusable hardware out there, where you can increase your payload capacity and decrease your cost. And the way we sell it is either to operators that are already launching and they want to have a hardware that is better, so increase their revenues and decrease their costs, or also through partnerships with organizations that have knowledge in the industry about ground operations, partners that are brokers and so on, and that can commercialize our payload capacity. And this is the idea, to provide these two kind of offerings. And to answer your question of are there interested parties? Yes, there are, both institutional and commercial organizations.
Perfect. You spoke previously about the additive technology you're using to print your engines. I'm guessing that's a big part of both your cost aims and the technology as a whole, as you said before, that it is a key element of enabling aerospike technology. What are the advantages and disadvantages of using this additive technology to produce your boosters and components for your engines?
Of course. I'll start with the advantages that are pretty clear. I mean, the most important one is design freedom. You could do with 3D printing what you literally cannot. It's physically impossible to do with, let's say, conventional manufacturing or milling, for example. So this is very, very important and very interesting for us because all the design on the cooling circuit of an aerospike, I can tell you that it's not an easy thing, and you need smart shapes to actually do it. And actually 3D printing enables you that. The speed, so actually it's pretty fast to print, and you have then your piece. Of course, people, it's important as well to educate and to teach people that it's not just having a design, pressing the print button and then something comes out, it's ready to test. Of course not. There's a lot of processes that you have to do after that, but even with all the processes, the post-processing, it's still faster than conventional manufacturing. It's cheaper. So currently there are not super big 3D printers. Just to give you a size order, we're talking here less than a meter into the plane, and you can go up to a meter in height, more or less. That's the state of the art. And so you have to find smart solutions on how to break it down into pieces to have this modularity. And yeah, I would say this as main disadvantages. The volume, you're still constrained by the volume.
And you forgot one very important advantage out there, Adri, which is the reduced number of parts. This is fundamental. Yeah. I mean, it's Absolutely. Quite amazing. The MOP1, which is a 2-ton engine, again, with more than 40 bar of chamber pressure and so on. So an engine, a proper engine, is printed in only 2 pieces. And this is amazing. I mean, the number of pieces that are there for Prometheus or other engines, we're talking definitely 1 or 2 orders of magnitude more.
Absolutely. Yeah.
You spoke about the smaller engine, you and the testing regime you went through with that smaller engine. Obviously, now there's the larger engine. What is the roadmap in terms of the testing of that larger engine? Are you planning a hot fire test soon-ish?
Yes. I can answer that. And before that, so Arcos is a 30-ton engine we are developing with a very a mindset of modularity. So in the sense that, as I just said, you cannot just have a super big 3D printers that print it in only 2 pieces as our smaller engine. Unfortunately, it's not yet the case. So we thought that why not making modular? What does it mean modular for this type of engine? That you could have separated combustion chambers in order to, if us or a client wants a little bit more of thrust, you can expand it. If you want a little bit less of thrust, you can decrease it a little bit. Of course, it will decrease a little bit in size as well. So this provides us the benefit of being able to test only one modular module, sorry, of the engine, and in order to iterate way faster, rather than having to print and manufacturing on all the engine and testing everything at a time. So we are targeting by the end of this year, beginning of next one, a module test already. Yeah.
Yeah, and just to come back on that, the certification of the engine, so fully certified for flight, meaning TRL 8 of an engine, because TRL 9 is validated in flight, will be reached in 2024. And I think this kind of speed is quite amazing also when compared to other programs. In our company, in less than 3 years, we were able to test this first demo P1 engine. And again, in less than 3 years more, certifying a fully ready for flight, a flight weight engine of 30 ton with new technologies, with advanced propellants, with advanced manufacturing. So yeah, actually, this is the roadmap.
Good. And in terms of the website, you talk about Arculus being a family of engines, being the first of a family of engines. Is this the idea of that modularity, or are you aiming for larger engines in the future, significantly larger?
So we are aiming for larger engines. So Arcus, let's say, is our baseline. Of course, as I just said, you can decrease it or augment it a little bit, but you cannot just double it with the same kind of modules, let's say. But yeah, the idea is to going a little bit in the lower part for why not upper stages, and also on the other parts. As I said, we are working already with the French Space Agency on how it will scale up on the meganewton class, and we are seeing that, as Xavi has explained before, on the economical point of view, on going bigger. So yeah, absolutely, we will target the meganewton class rocket engines as well.
In terms of launch facilities, I know, I mean, considering the way that you're talking, I'm guessing you are looking at a lot of options for launch facilities as well. Are you targeting to launch in Spain? I know that Spain is working on an orbital launch facility. I'm guessing Kourou is also on your roadmap. Are we looking for Sweden and Norway as well?
Absolutely. I will start by saying that the only one that has experience in providing this kind of operations is Kourou. So it's, I would say you have to understand it. And I think these are the most serious and advanced project that there is in Europe. Still, even the Diamond launchpad is not ready. And then there are other very serious and advanced initiatives all across Europe for the polar orbits in Norway, in Sweden. We've been discussing with them. We also looked at Azores because it's very well positioned geographically. And coming back to what you mentioned on the Spain launchpad facility, there are plans, but I don't know. I'm not aware of the level of advancement. I know that there is for suborbital. For orbital launch is it's another topic, and I'm not sure that I'm not sure about it.
Yeah. However, I just want to add up for us. Of course, it's a very important variable on the equation, but we have to be agnostic on that. We have to not care almost at all on the long term. So if a client wants to launch from there, why not being able to transport the piece of hardware that he or she needs and being able to launch almost from anywhere. So that is why we're launching. We're talking with everyone, and we're seeing that many people actually is also targeting and having innovative ideas as well on the ground segment part, on the launch pad, that many of us in the, let's say, doing rocket stuff, it's always like, yeah, it's the ground segment, it's doable. And many times we forget that even a launch pad could be even harder to design and to operate than the rocket itself.
Absolutely.
I mean, we talked thus far about MISO, about your rocket propulsion systems, but you're also developing in-space propulsion systems. Do you want to talk a bit about that?
Yes.
You want to answer that one, Xavi?
Go on.
Okay. So yes, we decided to go for that because it's a very interesting market and an expanding one, and we really want to, crush down all the knowledge we're learning from, very big rocket engines to the tiny ones, and for us, it was an opportunity. We saw that even CubeSats are more and more demanding for propulsion systems. There are a lot of competition, but normally it's a market a little bit easier to tackle because it's, you know, less populated with requirements and standards from, let's say, the big boys, the big industry players on the big satellites. So we decided to go for that and go with green propellants, easily storable liquid propellants, and having a monoprop and a biprop modes. And yeah, we're targeting a launch next year, actually, on our propulsion system, and it is called Unix. And yeah, it's advancing well. We are already doing some tests into this propulsion system.
Absolutely. I think it follows our strategy also on being focused on part of the hardware, right? But again, what we have to provide are transportation solutions. Not only maybe Pangea, we can be part of a servicing, right, to this kind of satellites. But if we believe our own story and so on, we have to be able to provide a portfolio of solutions that allow transportation. So we are good at propulsion, we are good at designing a space hardware, and this is what we are focused.
Perfect. You talked about the green elements of it and having green propellants. With Europe moving towards green propellants in space as a requirement, do you think that that's going to be a key selling point of your propulsion system?
I believe so. I think that the whole industry has to move towards sustainability. Again, this is a small sector up until now, but it's growing a lot. It will catch the eye of the general public. It is already doing so more and more. And I don't think that we can allow to continue to do things the way we did it up until now. So using toxic propellants such as hydrazine, I believe, but again, I'm not the decider on that, that will be way more difficult in the future than it is now, even banned. Probably. All satellites must have a deorbiting system at the end of life, and maybe it's not 25 years. In the future, it will be way lower, hopefully. Launchers cannot be orbiting. Parts of the launchers cannot remain orbiting second stages. It's quite surprising still that we're using this kind of approaches, right? And first stage is splash down and recovered only. Well, so our approach is to think that in 10 years, all of this has to change, and want to be able to again provide this kind of hardware. So for propulsion systems, yes, green propellants are definitely something we are looking at, and that we think that we have to substitute this kind of toxic solid hypergolic propellants that are out there right now.
On the sustainability, just to add on, of course, on the biosource, for example, methane, it's super important for this, and to add on what Xavi just said, but as well on the reusability. We do believe that whoever wants to start a rocket company in 2022, it has to absolutely focus on reusability. And not only, as I said before, not only on first stage reusability, which is, of course, has been demonstrated now, and now everyone is like, oh, this way of doing it works, let's go that direction, which is amazing from a nerdy, techie point of view, of course. But as well, why not going for the full reusability? Why not going for upper stage reusability as well? Of course, you will pay a penalty price, payload penalty price. But if you're reusable, the whole cost structure decreases, and you're not launching and giving and polluting space. And then, of course, if you are able to launch more often, then it on the mid-term or long-term, it pays off, because you're sustainable in the full word, the full capital letters word, because you're not leaving anything behind.
Perfect. And in terms of the split, obviously the bulk of your workforce is working on the propulsion, the main aerospike propulsion. What sort of size team is working on in this in-space propulsion project?
We do not share this kind of information publicly.
Fair enough. It's understandable. I figured I was taking a bit of a chance there. Perfect. And one of the questions I always like to ask is, Europe over the last 20 years has seen a massive brain drain in terms of some of our most talented engineers going off to the States and Russia, because that's where the market was. That's where the rockets were being developed. And if you wanted to be involved in exciting projects, you needed to go there. How important do you think it is for European companies, European space companies, to foster talent and to attract talent back to Europe? Do you think that's an important thing for European companies to be pushing?
Crucial.
It's absolutely pivotal to not only for us, but for everyone. I mean, I would say, one of the major challenges, hiring and creating a team of engineers or just people that are passionate about what they're doing, and this is super relevant. And as you said, there has been this brain drain, and now we are trying as quote to revert that back and trying to attract all those Europeans that then went there, but as well for the other way around. Why it should be always into one direction? Why not Americans could come to Europe to actually develop hardware and develop the sector? So we have to be more ambitious European wise and say, normally we look always on that side, like, oh, look at what they're doing, look at, oh, this is so cool, da, da, da. And like, no, come on, let's revert it back. Hey, we are doing very cool stuff as well. Why not? We can be for once leading the innovation and leading this space sector increase in all the domains. And of course, hiring and attracting people, it's super relevant, or at least it is for us. Yeah.
And we have experienced it firsthand. I mean, recently, for instance, Adri was discussing with people at, let's say, very well-funded launch startup in the US, engineers that were working there with very senior profiles, but they were not from the US. They were French, some of them from Spain, some others. Yeah. And it is surprising. We have to definitely reverse this.
Yeah.
Perfect. Xavier, Adrian, I really appreciate you sitting down with me for as long as you did. I think it's really valuable, the insights that we've got into Pangea. You guys have been one that I've wanted to connect with for a while, and I'm so glad I finally did. So I really appreciate you taking the time for me today.
Thank you for having us once again. And yeah, whenever you want, we can repeat.
Definitely. Thank you for joining me for my rambling conversations with interesting people. Keep an eye on my social media and your favorite podcast service for the next episode. Until then, remember, it's a beautiful day for launch in Europe.